Good morning everyone. Today, my group will be presenting a comparative study between Jewel Changi Airport in Singapore and Harvey Milk Terminal 1 in San Francisco. Our main focus is to understand how these two airports respond differently to their local climates through facade design, ventilation, daylighting, and environmental control systems. Both airports are large, modern transportation hubs, but they exist in two very different climatic zones, one tropical and one temperate, which makes their design approaches very interesting to compare. Let's begin with the climate background of each location. Singapore experiences a tropical rainforest climate. It is hot and humid all year round with high rainfall and minimal temperature variation. The challenge for buildings here is to reduce heat gain, control humidity, and maintain comfortable indoor temperatures. The airport features a massive toroidal glass dome roof that brings in natural sunlight into the forest valley at the center. The roof uses ETFE cushions, which help diffuse harsh sunlight and reduce heat gain, creating bright but comfortable lighting inside. One of the most iconic features is the rain vortex, the world's tallest indoor waterfall. Besides being a visual centerpiece, it also plays an environmental role. The falling water helps cool the surrounding air and supports natural ventilation by pulling warm air upward, allowing fresh air to circulate throughout the interior spaces. Surrounding greenery and water features further cool the environment naturally, while maintaining humidity and improving air quality. Overall, Jewel Changi uses biophilic design and passive strategies to create a comfortable, energy-efficient indoor microclimate suitable for the tropics. Meanwhile, Harvey Milk Terminal 1 in San Francisco responds to a much cooler and foggier environment. Since the city has mild temperatures, the terminal focuses more on daylighting and humidity control rather than heat reduction. The building design includes large clerestories and skylights that allow soft, diffused daylight to enter, especially through foggy skies, reducing the need for artificial lighting during the day. The terminal combines natural ventilation with mechanical HVAC systems. This hybrid system ensures air quality and temperature remain comfortable throughout the year, especially when outdoor conditions fluctuate between foggy and dry. Its facade design uses high-performance glazing, aluminum and steel curtain walls, and dynamic shading systems to optimize energy efficiency. These materials reduce heat loss in cool seasons while allowing controlled solar gain when needed. Through these strategies, Harvey Milk Terminal achieves thermal comfort, good daylighting, and efficient air circulation suited to San Francisco's coastal climate. When comparing both airports, their approaches clearly reflect their climate conditions. For air ventilation, Jewel Changi relies mostly on natural ventilation. The building's dome shape and the rain vortex create a stack effect that pushes hot air upward and allows cool air to circulate. Harvey Milk Terminal, in contrast, uses a hybrid system, a combination of natural airflow and mechanical ventilation, to adapt to variable outdoor conditions. Regarding the use of plants, Jewel Changi integrates a large amount of greenery throughout the interior. The plants help to cool the air, absorb humidity, and create a natural microclimate. In Harvey Milk Terminal, plants are used more modestly, mainly for air purification and rainwater filtration on the roof. In terms of water management, Jewel Changi's design makes use of water features such as the rain vortex to cool down the space while also recycling rainwater within the forest valley. Harvey Milk Terminal, however, uses a grey water recycling system, treating and reusing water for non-drinking purposes and filtering rainwater for sustainable use. For humidity control, Jewel Changi depends on natural elements. The plants and water features add fine moisture and regulate humidity without machines. Harvey Milk Terminal relies on its HVAC system to control indoor humidity, ensuring comfort despite external fog or dryness. Lastly, for natural sunlight, Jewel Changi's ETFE roof allows diffused daylight to enter while reducing glare and heat gain, perfect for tropical sunlight. Harvey Milk Terminal uses clerestories and skylights to bring in soft natural light through the fog, providing bright interiors without direct heat. In summary, Jewel Changi emphasizes passive cooling and shading, while Harvey Milk Terminal emphasizes lighting efficiency and mechanical regulation. To conclude, both airports show how architecture adapts intelligently to climate. Jewel Changi Airport embraces the tropical environment by using natural ventilation, greenery, and water to passively cool the interior and create a lush, relaxing atmosphere. Harvey Milk Terminal, on the other hand, responds to a cooler and foggier climate through controlled daylighting, hybrid ventilation, and high-performance facades that regulate temperature and humidity. Both projects demonstrate that successful design depends on understanding and working with the local climate, not against it. By learning from these two examples, we can see how climate-responsive architecture not only improves energy efficiency but also enhances user experience and comfort. Thank you.